Welcome to John's Maths Book. This video is going to build on previous videos and demonstrate how to simplify surds. We know that a surd is the irrational root of a rational number, and for accuracy is sometimes best left as a root rather than writing it as an irrational number, which will be an approximation and not accurate. So how do we simplify surds? To help explain this, we need to look at how a surd can be written. We can write a surd as a product of its factors. In the case of a square root, we can take the square root of a rational number and split it into its factors. If one of the factors is a perfect square, we can then take the square root of this number. Let's look at an example. The square root of 27. 27 is a rational number, but when we take the square root of 27, the result is an irrational number, and therefore the square root of 27 is a surd. However, rather than leaving it as the square root of 27, we can break 27 down into pairs of factors, where one of the factors is a perfect square. When doing this, it's helpful to either know or write down the factors of 27. To save time, I won't go through all the factors of 27, but I will use the factor pair 9 times 3. We know that this is 27, as 9 times 3 is 27, and that 9 is a perfect square. So let's see how it works. So 27, the square root of 27, can be written as the square root of 9 times 3. Now this can be written as the square root of 9 times the square root of 3. Now the factors 9 and 3 are both 9 times 3 is 27. Now 9 is a perfect square, so the square root of 9 is 3. So we can actually take this square root and rewrite this as 3 times the square root of 3. So let's look at another example of this and see how it works. Let's look at the square root of 30. So the square root of 30 can be written as the square root of 60 divided by 2. Now, we know that factors of 60 are 15 times 4. So we can write this as the square root of 15 times 4 divided by 2. And as we can see, with division, we can now break this up as the square root of 15 times 4 divided by the square root of 2. So we've got factor pairs of 15 multiplied by 4, and we know that 4 is a perfect square, so its square root is 2. So we can rewrite this as follows. So we can say this is the square root of 15 multiplied by the square root of 4 divided by the square root of 2. So we know that the square root of 4 is 2 because 4 is a perfect square. So this can be further rewritten as 2 multiplied by 15 divided by the square root of 2. Now it's important to note that this technique only works with multiplication and division. When we have addition and subtraction, it doesn't work. So for example, the square root of 11 is not equal to the square root of 6 plus the square root of 5. So we need to remember this. So let's do some examples of simplifying surds. So if you feel like pausing the video, please do. Have a go yourself and then restart the video. So our first example is the square root of 20. So 20 has factors of 4 times 5. So factor pairs 4 times 5. So we can rewrite the square root of 20 as the square root of 4 times 5, which we can write as the square root of 4 times the square root of 5. Now we know that 4 is a perfect square, so we can actually take its square root. So we know the square root of 4 is 2. So this becomes 2 times square root of 5. So in our second example, we have the square root of 32 divided by 45. So let's look at those numbers individually. So 32 has factors of 16 and 2. So 16 times 2 gives 32, and 45 has factors of 9 multiplied by 5. So we can write this as 16 times 2 divided by 9 times 5, and that's square root of everything. So this can be written as 16 times 2 divided by square root of 9 times 5. So if we take a closer look at the factors, in the numerator we have a factor of 16, which is a perfect square. And in the denominator we have a factor of 9, which is also a perfect square. So we can rewrite this all as the square root of 16 times the square root of 2 divided by the square root of 9 times the square root of 5. So if we now take, in the numerator, if we now take the square root of 16, we get 4, and that's then multiplied by the square root of 2. In the denominator, if we take the square root of 9, we get 3, and that's multiplied by the square root of 5, which is not a perfect square and therefore an irrational number. So in our third example, we have the square root of 40. So this can be broken down into factors of 4 times 10, which is the same as the square root of 4 multiplied by square root of 10. So we know that 4 is a perfect square, so we can go ahead and take the square root of 4. So the square root of 4 is 2 multiplied by the square root of 10. Now the square root of 10 is an irrational number, so we leave it as the square root of 10 for accuracy. So it just becomes 2 multiplied by the square root of 10. So in our final example, we have 48 divided by 54 and the square root of that. So we can take each of the numbers, so 48 and 54, and break them down into factor pairs. So 48 has factors 16 times 3, and 54 has pairs 9 times 6. So the square root of all of that. So that can be written as the square root of 16 multiplied by the square root of 3 divided by the square root of 9 multiplied by the square root of 6. Now in the numerator we can see that we have 16, which is a perfect square. So we can take the square root of 16, which we know is 4. And that's multiplied by 3, multiplied by the square root of 3, which is an irrational number. So we just leave it as the square root of 3. And in the denominator, we have the square root of 9, which we know is 3, because 9 is a perfect square. So 3. And that's multiplied by the square root of 6. The square root of 6 will be an irrational number. So we leave it as the square root of 6. So that concludes this video on how to simplify SURDS. If you like these videos, then please like, subscribe, share, and comment as usual.